right, this is 8th grade science review. So I'm just going to basically go through, give you a little second or so to answer the question, and I'll give you the answer. So this should help you more than just reading through things and not reviewing. Anyways, the most important instrument used by astronomers is the telescope. The telescope that uses lenses is called refracting telescope. The one that uses mirrors is called reflecting telescope. The part that you look through is called the eyepiece, and the one that's at the very end, the lens that's at the very end, is called the objective lens. The objective lens. Americans who fly into space, or sometimes just people who fly into space, are called astronauts. Russians who go into space are cosmonauts, and Chinese who go into space are taekwonauts. Taekwonauts. There. Computer-controlled mirrors that constantly flex and bend to correct the atmospheric distortion. This would be considered adaptive optics. Adaptive optics. What did they put out in space to correct their atmospheric distortion? The Hubble Space Telescope. What is a wave that consists of an electric field and a magnetic field? They're vibrating back and forth at right angles to each other. That's the electromagnetic wave. The electromagnetic spectrum is what they put all the different types of electromagnetic waves on. Anything from radio waves, microwaves, infrared, ultraviolet, visible light, X-rays, gamma rays. That's from the lowest to highest frequency. There was not a question there, just review. Dark narrow lines that whenever they're studying the spectrum may appear are called absorption lines. And a device that splits light into a spectrum for analysis. A device. Spectroscope. Yes, of course we can use a little prism, but this is like technically a device that does this. And if it goes towards the red end of the visible spectrum, it's called the red shift. If it goes towards the blue end, it's called the blue shift. They also use low frequency electromagnetic waves that the human eye can't see, and these radio waves can be used to help with radio telescopes, and most radio telescopes have that large dish that kind of all the microwaves, radio waves are reflecting down onto that, kind of like the one at Green Bank. The resolution of radio telescope images can be increased dramatically using what they call this technique. It analyzes the radio waves. That's interferometry. Interferometry. The point directly overhead, and we're talking about celestial sphere and all of that now. The point directly overhead is the zenith. The point directly below you would be the nadir. And the important circle on the celestial sphere, kind of defined as, it's like relative to the observer, full circle that connects both celestial poles. It is the meridian. Meridian. One rotation of the Earth relative to the stars. We're talking about time, day and night, that kind of thing, days and all that. This would be considered, if it's related into the stars, it is a sidereal day. If it's from noon to noon, it is an apparent solar day. If it is the average time of a solar day, it would be mean solar day. We also call daylight savings time this summertime, and we go by this where our day is divided into two equal parts, 12 hours each, and that is called 12-hour time. But a military may use this, which is divided into one group of 24 hours, and that is 24-hour time. The time it takes the Earth to orbit the sun once is called a solar year. The time that it takes for the moon to orbit the Earth is called a lunar month. Lunar month. A week isn't based on the heavenly body. That's the only one that's not. We look to the Bible for that one. A couple different calendars. Which one do we use? We use the Gregorian. Get the names from the Julian, but the Gregorian's the one that we use. Also Jewish and Islamic calendars out there. All right, the path of the ecliptic and the paths of the sun and the moon and us. That's what we're talking about next. The path on the celestial sphere that the sun follows in a year is called the ecliptic. So the sun's path is the ecliptic. The ecliptic intersects the celestial equator at 2 points. Those points are called equinox. So you have two different kinds. You have the autumn equinox, autumnal equinox, and the spring or the vernal equinox. Now you've got those two equinox, so the parts that are in between the two equinox would be called what? Solstices. So solstice would be midway between the two equinoxes, and that would be summer and winter solstice. There. Moving on to the history of space flight. All right, I'm going to kind of hammer these out pretty quickly. All right. The American engineer that became known as the father of modern rocketry, Robert Goddard. He invented the what fuel rocket? Liquid fueled rocket. Before that, fireworks and military rockets, they used what kind of fuel? Solid fueled rockets. Who was the German who made great advances in rocketry in World War II? Werner von Braun. You have to say it like that. Then we begin the space race. October 4th, 1957. The Soviet launched the first artificial object into space, and that was called Sputnik 1. And then, of course, they did Sputnik 2. And then finally, 3 months later, America's first satellite was Explorer 1. Then they put the first, Russia put the first, or I should say Soviets then. Soviet Union put the first person to travel in space, and that was Yuri Gagarin. And a month later, the first American in space was Alan Shepard. And then the first American to orbit the Earth, John Glenn. And then the first female to be in space, she was from the Soviet Union. That was Valentina Tereshkova. Then the Soviets accomplished another first by launching a 3-cosmonaut spacecraft, and that was Voskhod. And they actually had a EVA, or extravehicular activity, even on that one. And then we did 10 space flights that were manned, more than one man, a series of 10 manned space flights. And that was called what program? Gemini program. And that's when we really started taking off. And then finally we launched the program that actually put a person on the moon, and that was Apollo program. And Apollo 11, of course, being the first one. And the first man on another world was Neil Armstrong. All right. Then the Soviets came along with the space station. The first space station was Salyut. And then the United States launched their first space station, which was called Skylab. Then the Soviet launched another space station that was designed so extra rooms could be added onto it, and that was called Mir. And then Reagan says, enough of this going back and forth. We need to take all of our resources and put them together and make up something that the world can work together on. And over 15 nations by 2000 were working on this, and that is the International Space Station, the ISS. Then you have a new type of spacecraft, which was designed to be reused, and that was the Space Shuttle. And of course, America launched that. And then they retired the Space Shuttle, and the Russians came up with a special spacecraft for the primary way for the for everybody to be able to get to the ISS, and that was Soyuz, Soyuz, Soyuz. All right, and then still, we're the only ones, the Americans are the only ones that have set foot on the moon. America and Russia, for a long, long time, were the only ones that were in space. And then now, China in 2003 put a taikonaut out there. And now, of course, we have others who have been to the International Space Station that work with us. All right, orbits and satellites. Let's review a little bit about that. The highest point of an orbit is called apogee. The lowest point of an orbit is called perigee. The type of orbit that stays above the same point on the Earth's surface, it tends to go with the Earth at the equator. Geostationary is what that is, geostationary. The one that goes perpendicular to the equator through the poles, polar orbit. And sometimes those are sun synchronous as well. What is the orbit that allows a satellite to transfer orbits? It's called the Hohmann transfer orbit, or the transfer orbit. There. All right. Then we have different types of satellites. The one that is, I'm gonna mix these up. The one that is used as a military outpost has missiles and cameras and such on it. That would be a military satellite. The one that is used to aid GPS and help us to move around, that is navigational satellite. The ones that are used in meteorology to study the clouds and the weather, rocket science, weather satellite. And then the one that's for TV and telephone conversations, that kind of thing, communications satellite. The ones that just study the heavens, they study everything out there in space, other planets and such on, so on and so forth. Astronomical satellites. And then the ones where we can just do all kinds of surveys and storms and crops and forest fires, and we just basically look at the Earth and study it. That is Earth observation satellites. I will tell you, you need to know all those different types of satellites and what they do. Pretty easy, though. It's common sense, their names. An unmanned spacecraft launched specifically to explore the unknown is a space probe. And then the speed that is needed to get out of our atmosphere and escape the gravity of the Earth's pull, and that would be escape velocity. All right, so you can use this video as much as you possibly can over and over to get all of what you need down in chapter 11 and do that study guide and for 10 and 11 and those activities. Don't forget that. Have a good week.